Good afternoon, students. Welcome to today's class. So in the last class we studied completely about electric current, right? So you need to keep recalling all those things. So in today's class we'll be starting another topic, that is nothing but electric potential difference. Now look at the term electric potential difference. What is this difference? It is nothing but finding something between two terminals. No, that is nothing but difference. So let us see what is the exact definition of electric potential difference. Now what is this potential? For example, in any electrical circuit, to flow the current, potential is an important term to flow the current in an electric circuit. So understood, right? So here only for the brief explanation we'll be using what is kinetic energy, what is potential energy, which you already know, but in a very simpler manner I'll tell you the definition of this electric potential difference. So it is nothing but, you all know, in an electric circuit, of course we'll have two terminals now where the current will start from flowing from one point to the another point. So here the amount of work done to move a unit charge from one point to the another point is called as electric potential difference. Now look here, electric potential also depends upon charge, which we studied in the last class. Now once again we'll recall. Now what is this electric potential? The electric potential difference between 2 points in an current carrying circuit. So it is that the amount of work done to move a unit charge from one point to another point, and difference between those terminals is nothing but electric potential difference. So all you want to remember is only this statement, which is easy, right? Now listen, electric potential is denoted by the letter that is capital V. Now the SI unit of potential difference is also denoted by the same symbol, that is V. What is this? This is nothing but voltage, right? Now potential difference is denoted by with the symbol capital V. At the same time SI unit also is the same symbol, that is volt. Now let us see the formula for this potential difference. So potential difference, which is denoted by V, is nothing but, look at the definition. Always remember, definition indicates the statement. Just by looking at the statement we can write the formula. So here what we have, work done to move a unit charge from one point to another point. Work done to move a unit charge, right? So look here in the definition what we have, work done and charge. Therefore potential difference is equal to work done divided by charge. Work is denoted by capital W and charge, which we already know, that is Q. Now V is equal to W by Q is the formula of potential difference. So suppose if I write this in terms of SI units, what I will get? SI unit of potential difference is nothing but same now as I told earlier, that is V. So what is the SI unit of work done, which we already learned, that is nothing but joules. Now charge is nothing but coulomb. So suppose if you get a question, define 1 volt, what you will write? So 1 volt is nothing but joule per coulomb, or both are same, right? Now we finished electric potential difference. So next one problem we'll solve from the textbook. So here all are the example problems. So look at your textbook. 12.2. How much work is done in a moving charge of 2 coulomb across 2 points having potential difference 12 volt? Now as I told earlier, by looking at the problem what we need to write? So soon after looking at the problem, all we need to write is given. So what is there? Work done they are given. How much work done? Work done we need to calculate, that means W we need to calculate. 2C, C nothing but coulomb, that means we need to indicate Q is equal to 2C. Potential difference, what is that? We know V is nothing but 12 volt. Now what is the formula? V is equal to W. V is equal to W by Q. Now this is the main formula. Based on the problem we need to modify that one, that means we need to find out W as it is small substitution, that is cross multiplication, V into Q is equal to W. This is our main formula for the problem. Now what is V? V is 12, Q is what? 2 is equal to W, that is nothing but 24. Now what is the unit of W? That is nothing but joules, right? So the unit of work done is joules, therefore the answer is what? 24 joules. Now listen, these are very simple question which you will get for 1 marks, and again remember the same question you will get in the form of MCQs also. The same question they will give with different option, so just you need to identify the proper answer. So let us move to the next topic. So the next important topic is electric circuit, which you already learned. So once again we'll repeat this one. So what is electric circuit? Circuit itself, you can easily observe that it will start with 2 terminals. For example, suppose if you assume battery contains 2 terminals, right? A positive, one negative. So current will start flowing from positive to negative, correct? No? So here, how to define electric circuit? So in the electric circuit, where continuous conducting path between the terminals and with respect to electricity, right? So here is the definition of electric circuit. A continuous conducting path. This word is highly important. You need to rewrite the same thing for the definitions. A continuous conducting path between the terminals of a source electricity is called as electric circuit. This is the definition. Now our next topic is circuit diagram. Now look at the term circuit diagram. Here we have what? Diagram. Now how to define this one? It is nothing but a drawing which shows various electric devices are connected in it. So this completes the circuit diagram. Correct, no? So here we need to understand in a circuit diagram various components will be connected. So for example, let us draw a simple electric circuit. So as I told, a main source of this one is what? Battery. Now here always remember, in a battery, see, we are indicating 2 lines. A longer line will be always positive terminal and the smaller one will be negative terminal. Therefore, you should also write in the similar way. One is long and another one is small. So here, circuit, in the circuit mainly we have key. Key is what? It is nothing but switch on and off button. So suppose if I keep a dot in between this bracket, so then it is nothing but, so here if I keep, it indicates closed, that means off. If it is open, if it is no dot in this means, then it is called as open circuit. Now what are another things which we can indicate? Let me take just an ammeter. It is a device which shows the current value. So let us connect one bulb here. So here if we on, the current will pass and the bulb will glow. If we off, current will off and bulb doesn't blow. That's all, right? So here, after writing this simple one, now what you need to do? You must and should indicate the direction of a current. Now listen, current will always start flowing from the positive terminal to negative. That means from this direction. So it is must and should in each and every diagram. Okay, current will start flowing from here. So this is a simple circuit diagram. Now our next topic is nothing but a commonly used circuit elements or components. See, here I just used one, what is this? Key, and this is an ammeter, and this is a bulb, and these are the battery, or we can call this as a cell. So just like this, we need to understand few more components which will be used in the circuit diagram. So let us understand one by one. Clear? So first it is there in your textbook with the colorful one tabular column. You need to rewrite the same exactly in your notes. Okay, so cell. Now listen, cell is nothing but one positive and one negative terminal. This is called as a cell. Okay, suppose if the same cell, that means we have number of cells together joining to one another, then it is called as battery. Now how that looks? This negative, after negative it will always connect to the positive only, that means long line. Again short, again long, again short, again long. So this is one cell which is connected to the another cell, and this is connected to the another cell, and this is connected to the another cell. Now this is called as battery. Now once again, if this is a long one and another end, it should be a short one only. Okay, now once again, what is battery? Battery is nothing but combination of cells. So 1, 2. So next what we have is nothing but plug key. In other words, we can also call it as switch. Now plug key will be indicated like this. Now what is this? These wires, these are nothing but connecting wires. Our source is only this much. This is what we need to know. But always we need to show this line also, because circuit diagram is what? we have a connecting wires to connect from one component to another, another to another, right? So these are nothing but connecting wires. So here we are indicating like a bracket, and it is nothing but what? It is a plug key. In other words, we can call it a switch. Now listen, if you are not keeping any dot here, that means if it is a plain, then we'll call it as open circuit. Clear? So next one, same. If I keep a dot here, same thing, same switch, but it is closed one. Clear? So how many of you missed? 1, 2, 3, 4. And the next one is, so this is called as wire joint. So as I told, these are what? These are connecting wires, no? So whenever it is necessary, we need to join them. That means it will be covered with insulated wire. Inside only we'll get a conducting material. So using some materials, we need to take that insulator in between, we need to connect that one, and this particular joint is called as wire joint. Okay, so next, sixth one. So what is that? This is wire joint, and the next one is wire crossing without joining. Now how I can write? See, if this is an conducting wire, I need to pass one more conducting wire without joining to this wire. How I can do it? It is nothing but, so another wire is coming from this, without joining this one, I need to cross. So this indicates there are two wires, but they are not joined to one another. Clear? Cell, battery, plug key, open and closed, and this is wire joint, and this is wire without joining. Now the next one, seventh one, is nothing but what we just wrote here. What is this? Electric bulb. So usually we'll indicate like this, an electric bulb. If not, you can also draw the actual picture of the bulb. Clear? And next we have called as resistor. Now what is exact meaning of resistor we'll be seeing in the next topics. After this we have one topic called as Ohm's Law. Next to Ohm's Law we'll be studying what is exact meaning of resistor. Now just understand how exactly the resistor device looks like. So resistor, which be a resistor or resistance. So this is how it looks, symbol. Clear? So about this, as I told, we'll be discussing later. So resistor looks like this. And next what we have is variable resistance. Variable resistance. In other words, we can also call this one as rheostat. So next only the Ohm's Law will use. So variable resistance and rheostat looks like same as this resistance, but here we have one arrow mark, or we can also draw like this. Okay, so we have two symbols for this one, that is variable resistance or rheostat. Any one we can use. Clear? So we finished 9th, and we have only two more, that is 10th and 11th one. That is nothing but ammeter and voltmeter. Usually, see here we used this one now. So ammeter will be indicated with A in a circle. Further, it will be connected to the connecting wires. Now voltmeter is indicated as it is, that is with a symbol V in a circle. Further with connecting wires. Clear now? So ammeter as A, voltmeter as V. Now listen, where we used ammeter? Here. So ammeter always gives the values of current. So ammeter will give what? Values of current, and voltmeter will give the values of potential difference. It is nothing but V, voltage. So it will give the readings of potential difference, and this is nothing but current. And how they will connect? Ammeter will be always connected in series, and voltmeter will always connect in parallel. Now what is this series and parallel? After two more classes we'll be understanding exactly what is series and parallel. Again we'll recall about this ammeter and voltmeter. Now I hope you understood exactly about what is electric circuit and what is a circuit diagram, how to write a simple circuit diagram, and some 11 important components which we'll be using in a circuit diagram. Now how will get question? Of course they won't ask define electric circuit. What they will ask is write a simple circuit diagram, or if not, they can, out of these 11, they can take any 2 for 1 marks or any 4 for 2 marks. That means each contain half marks. They will give write the symbol of battery, plug key with closed or open, and write the symbol of rheostat or resistor. Clear? So it is important. Okay, next we have an important topic that is nothing but Ohm's law, which we'll study now. So you can just, before watching this one, open your textbook, which I'll be sending in the PDF form. There you can see 12.1 activity. First read that one. Read the complete activity, what the procedure given in the textbook. Then watch this one. Okay. Then you will understand clearly. So here we'll be understanding the activity 12.1. So here all we are understanding is the relationship between potential difference and a current. That is what V and I. So here, look here. I draw one circuit diagram, and you all know that what is this this point is called as cell, right? But we have combination of cell, that means I can call this as a battery. Clear? And this one is what? Positive terminal, and this is negative terminal. As I already mentioned, current will flow from where to where? From positive to negative. So it's must and should you need to draw the direction. Yeah. Now see, this positive terminal is connected to a resistance. So this is the symbol of resistance now. So let us name these two terminals as X and Y. So here positive terminal is connected to resistance, and this resistance is made up of a wire called as nichrome. Now what is this nichrome? Nichrome is nothing but an alloy. Now what is alloy? Everyone know, no? Alloy is nothing but a mixture of metals. Now it is the mixture of nickel and chromium. Nickel will be in a more percentage and chromium will be in the least percentage. So here we are taking nichrome as a resistance material. Why we are choosing only this one means this has a very high resistance. High resistance. Okay, yeah. Now here we have a nichrome wire, which is again connected to the, what is V? V is nothing but voltmeter, no? Which is connected to the voltmeter in parallel. And further, this resistance is connected to the ammeter in series. As I already mentioned, what is series and parallel? After 2 classes, we'll be clearly understanding that one. Now just see this one. Further, this ammeter is connected to plug key, and further it is connected to, not yet connected, but we'll be connecting one by one based on the procedure. Now listen, we marked here positive and negative. Always remember, the positive terminal will be connected to the positive side of an ammeter. So ammeter, voltmeter, both of them will contain 2 terminals, again positive and negative, positive and negative. So this will be connected to positive, further it is as usual negative. So this is also same thing happens to voltmeter. So this side is positive and this side is negative. So first you need to draw the sketch, then you need to mark all the necessary terms which is required to complete the circuit diagram. Now everything is connected, no? Everyone understood how exactly the circuit is connected with the components. Now, so here we need to conduct an experiment based on the procedure. So with respect to that procedure, we need to draw the tabular column. Look at the tabular column which I already written here. Exactly I copied from the textbook. So only I mentioned you to read from the textbook before watching this one. So see here. So we have 1, 2, 3, 4, 5 columns. So first one is nothing but serial number. So this is nothing but different trials. So here I wrote 1, 2, 3, 4. And next, number of cells used in the circuit. So if this is a battery, each one of this called as a cell, right? So since we are counting each cell, that's why we wrote differently. So how many cells I'm using here? Cell number 1, cell number 2, cell number 3, cell number 4. It will continue as I'll repeat the experiment. So 1, 2, 3, 4. Let me write that one here. So 4 indicates what? 4th cell. So from where I'm counting? From this point I'm counting. Now I indicates what? Current. So current through nichrome wire. That means once when I started switching on this plug key, the current will flow. Automatically we'll get the reading in ammeter and voltmeter. So these two are the devices where they will show the reading of current and here reading of potential difference, and that one I need to note down in these two tabular column. Clear? Now let me start first one. So here this wire where I still not yet connected to any particular point now. So this wire should be connected to the first cell. So that's why here I have a first trial. So this is the first cell. When I connected this one, after switching on the circuit, I will get the reading in ammeter and voltmeter. So current reading I need to note from ampere. So a rough values I'll be taking. So suppose when I connect to the first cell, I will get one value, let it be 5, let it be 1 ampere. So this is the rough value, so that we need to get an end point. And next, simultaneously after getting I reading, that is current reading, at the same time we'll also get one more reading in the voltmeter. So here I may get 5 volt as a reading. So it's not like this whole number, it may also will get decimal 0.1 or 0.2. So when we'll do the actual experiment, based on that we can note down the readings. So here, this is what number of cells used. Now I'm connecting this one to the second cell. So here I got random reading called as 2, and here I got 10 volt, and same thing I need to repeat for each and every cell. So here I can note it down. It's not necessary to write ampere each and everywhere. So if I written in the tabular column heading, it's okay, no need to write. So here 4 ampere, and here what 15 and 20. So based on the procedure, we finished the experiment. So here we need to count down V divided by I. Now V is what? This value, and this is I value. 5 divided by 1, how much will get? 5 only. 10 divided by 2, how much will get? 5 only. 15 divided by 3, 5 are 24, 5 are. So what we got? 5, 5, 5. So some value we got. Now after conducting, after taking all the readings and after calculating, we need to draw the graph. The graph, so x-axis should be current and y-axis should be potential difference. So we need to plot the graph based on these values. So you know how to plot the graph, plot it everywhere. So we will get something points like this. So when we join each and every point, we can observe that from this experiment we will get an linear straight line. Clear now? Only this much what we need to learn from this activity. At last we'll get to know what is the main conclusion from this activity. Now listen, for your main exams, that means from the examination point of view, they will always give draw the circuit diagram which is used in the Ohm's law activity, or they will ask you to explain the activity. So you need to remember this tabular column, and you can just write the same values. If not, they will give the tabular column and they will leave empty places which you need to fill by looking at the either side of columns. If not, they will frame a question based on the graph. For MCQ mainly you will get different types of a line where you need to indicate. All we get from the Ohm's law is nothing but straight line. Clear? So here this activity was explained by the scientist, that is German physicist, in the year 1827. He is nothing but George Simon Ohm. So Ohm, you need to remember this one. So this scientist explained the activity or experiment to give the relationship between potential difference and current, and this activity named as Ohm's law. Understood? So this is just an experimental explanation for the Ohm's law. Now let us see what is the exact definition of Ohm's law. Ohm's law states that at a constant temperature, why this constant temperature is necessary? We'll be taking a resistance based on a requirement of a experiment. So which one we took here? Nichrome wire. So we should have a constant temperature throughout all the trials. Okay. So at a constant temperature, the potential difference across the ends of a given metallic wire. Always remember, potential difference we will be measuring between two terminals only. No, that means difference means what? We need to measure a value between any two terminals. So you need to mention across a given metallic wire or a given conductor in an electric circuit is directly proportional to the current flowing through it. Now listen, this Ohm's law definition is important and you need to reproduce as it is from here to here. So once again I'll repeat. So what is the definition of Ohm's law? At a constant temperature, potential difference across a given metallic wire in a circuit will be directly proportional to current flowing through it. Now the same definition I can make it to formula, that is nothing but what? V is equal to, that is what? Potential difference is directly proportional. Sorry, it is not equal, it is directly proportional. So directly proportional to what? To current flowing in the circuit. That means V is directly proportional to I. Clear? Now here it is not our end formula. That means we need to remove this proportionality constant by taking any terms. So let me take this one. V divided by I is equal to any constant. Now this constant is nothing but we are introducing a term called as R. This is our proportionality constant, which is called as resistance. Now V divided by I is equal to R. So a simple cross multiplication, I can write it as V is equal to IR. Now listen, this is a mathematical expression for the Ohm's law. Clear? Once again I'll repeat. So this is a statement. Based on the statement, we can write one equation that is nothing but V is directly proportional to I. I is nothing but what? Current. Potential difference is directly proportional to current. We need to remove the proportionality constant by introducing a constant term that is nothing but resistance. So here we are taking resistance. Then after a modification we got V is equal to IR. If you get 1 mark question just to write an equation, mathematical equation for Ohm's law, you need to write this one. If not, if they ask how you got this one, just write from this point to this point. Clear? Now listen, what is this term? R. R is what? Resistance. So our next topic is resistance. Now we'll be studying exactly what is resistance, and one more term we'll get here, resistor, and again with an activity we'll be learning a lot about resistance.